This is a little Banggood kit that supposedly is a tone or a doorbell type thing. I don't really know. So it comes with the usual cast of characters, some resistors, a power diode, although I don't know why, 2 small signal diodes, a header, a switch, and I believe the tones are stored on this. It's a little circuit board with a monolithic chip on it. These 2 small signal diodes with the glass body will go here and here. And this diode with the epoxy body will go here. So we'll go ahead and install the resistors first. And we have a package of 6, although I can only account for 5, 150K resistors. And the color code on that resistor is brown, green, yellow. 1, 5, and then 4 zeros. 150,000. And I'm going to make the resistor colors read the same way as the writing on the board. So we'll just bend the legs at right angle and pop the resistor in like this. There are 5 150K resistors installed. There may be one more. I haven't found it yet. They gave us 6. But try not to throw them all away. Finish off this row of components. We have our 2 small signal diodes here. One end of the diode is marked with a black band. On the silk screen, that black band is marked by the double-ended lines here. So the polarity of these diodes is important. Electrically, the resistors could have been installed in either direction, but electrically, the diodes only go one way. There's another diode here, D3. This diode, the end is marked with a white band, you can barely see there. And the silk screen is marked by a double line on the end that the band faces. So we have our 3 diodes installed. Here there are the 2 1N4148s with the glass body diodes. And here is the epoxy body diode. We need a 62K resistor right here. And that is a blue, red, orange. The silver is the tolerance. Blue is 6, red is 2, and then orange is 3 zeros. There is also a 620K. 620000. That will be a blue, red, yellow. The blue is 6, the red is 2, and the yellow means 4 zeros. 620K. The last 2 resistors are 270K each, and we have 2 resistors here. The color code on these 270K resistors is red, violet or purple, and yellow. 270000. This is the board with all of the resistors and diodes installed. And they all fit very close to the board. They don't stick up above my little blocks. We have a capacitor here. It's marked 104. And there's a hole, pair of holes, marked 104. And we have a transistor, and you see it's rounded, a round body with a flat side to it. The silk screen indicates a round body and with a flat side. That's called Q1. There's 3 holes, 3 leads. Install the transistor and push it down. Like so. So we have all the through-hole components installed. We need to install the switches. Of course, the little vertical sound card. But I think I'll install next the 2 integrated circuit sockets. If you look closely at these sockets, you'll see there's a divot at this end of this socket and this end of this socket. It corresponds with this indent or divot on this circuit board silk screening. You notice I've got the notch or divot in the end of this. The socket lines up with the silk screen in both cases. And over 2 diagonally opposite pins in each socket. That'll serve to keep the sockets from falling out. And I'll solder those 2 bent pins on this socket and 2 bent pins on this socket. Take my thermal barrier, position it so I can squeeze the socket. I'll heat the socket up and then squeeze it. Don't squeeze it until the solder's melted. That will ensure that the socket is flush against the board. Now we do all the remaining pins. The little speaker is polarized with the plus sign. That has to match with the plus sign. We'll cut off 2 of these pins. And we'll place the 2 cut off pins in the 2 holes with it has a plus sign on one corner. And then we'll install 4 switches. They'll go in like this. Now this little sound board is supposed to be mounted down in this opening, like that. And it needs to be perfectly centered, end to end. Needs to be perfectly centered end to end. And then you can make a 90-degree solder joint at each one of these pads. Well, to do that, you would have to put this on the board first, because these components are in the way. The board would line up like this, except this way. Now it appears as if there's a hole in the board for each one of these pads. But there's not a hole in the board for this hole. This hole ends up being not used. It's this pad that goes to this hole. This pad goes to this hole. On. But this hole is not used. This pad is used. Now these 2 holes are designed to be connected from the reverse out through this hole and down through this hole. I obviously don't intend to do that. What I intend to do is take some of these wires that are piled up here. They're trimmed off leads. And they intend to stick them in the hole, but not this hole. Here I'll solder the wire to the pad. Here we are with all the wires. One wire in each hole, except for this hole. Now it helps if you cut the wires so that they get shorter. Then we'll just place them in the holes on this side of the opening. They're like that. Now then, find some nice long leads. They will have to go from this hole to this hole. So it's coming up from the blue board, going in the back. There's not going to be another one here. It needs soldered on the front of this board. Now we'll do it one more time. We've got this 2-pin header here. This one's positive and this one's negative. It's marked on the silk screening. I've got a banana by DuPont connector cable. Make sure when you're inserting the ICs that the notch on the chip or the marking on the chip lines up with the marking on the circuit board. Squeeze the chips in. We'll take our power connector. We've got 4 on-off switches. That allows us, using binary, to count to 16. We've got an A, B, C, and D connector and a ground. We could put 4 switches here, hook one side of the switch to ground, and then open and close those 4 switches, grounding or ungrounding, whatever we choose. And this function of switches here could be duplicated remotely. As far as reprogramming the sounds, they are on the chip. And by the way, I'm supplying this with 5 volts, and it draws a current of about 100 milliamps. Let's see, Alice charged $2 a piece, I guess, for these, because I ordered 4 of them, and they cost me $10. $2.50 a chip. $2.50 for a low-quality music maker.